Hi guys, we'll just wait 2 minutes more, then we'll just start off with today's session. Okay?
Okay, ma'am.
My voice is
Okay,
audible?
ma'am.
Yes, ma'am.
Okay,
Yes,
okay,
ma'am.
Yes,
fine.
ma'am.
Okay, fine. We'll just wait 2 minutes, then we'll start.
Okay, ma'am.
Okay, guys, I'll just share my screen. You let me know is it visible or not. Okay, we'll just start off with the session.
Okay, ma'am.
Yeah,
Yeah, ma'am.
okay, just a minute. Visible? Screen is visible?
No, ma'am.
Not yet, ma'am.
Okay,
No, ma'am.
okay, okay, just a moment. Now?
No, ma'am.
Okay, just a minute, guys. Now visible?
Vi- Visible, ma'am. Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay,
Yes, ma'am.
okay, fine. Got it. Yeah. So yesterday we have just started with ridge regression, right?
Yes, ma'am.
Okay, fine. So today we will be just going through and see what ridge regression is, which will just recapitulate ridge regression once more, and eventually we'll move ahead. Okay. So what we are actually like, anyone can recall what we have learned about ridge regression?
It's a type of linear regression with regularization, L2 regularization. It is used to
Yeah.
prevent overfitting when the model is too complex or bulky.
Mm-hmm. Right.
And it adds a penalty term to the cost function.
Exactly. Right. Yeah. So we have gone ahead and learned till y when y equals to the formula as well, right? Yesterday
Yes, ma'am.
we have gone ahead and learned about the form and the how we are checking it through, that we have learned, right? So we'll just recapitulate it once more and we'll go ahead accordingly. Okay. So accordingly, reg regression is we can think of it is just a special version of linear regression. So what happens in case of linear regression, we try to find the best straight line or the plane or the hyperplane, like basically straight line in the sense plane or a hyperplane, because we are seeing it in 2D format. We are taking into form that it is coming up in that format. Like, see, here we are putting it in 2D format. So we are seeing it in a line format, but actually we are getting it in 3D, right? So it will be either plane or hyperplane. Okay, that fits the data accordingly, right? So we have already discussed some of the features related to linear regression, right? So what are the features like related to linear regression that makes linear regression unstable? That are the features. Suppose the x value that we are taking into consideration are highly correlated, right? So there are suppose there are situation where there are too many features are there comparative to the data points. Suppose the features, the number of columns are more irrespective of the number of rows that we are getting, and there are conditions where the model starts overfitting, right? Like what actually it is doing, the model is memorizing instead of learning, right? So in that very section we are actually trying and using this ridge regression. When linear regression become unstable in this certain cases, we use the ridge regression. So ridge regression actually fits by adding an extra penalty or an extra cost on the large coefficient that we are getting. That is the slope value we are getting. There it is adding an extra cost. Okay. So what are the basic things that we need to consider up here? We'll be going through that. So what are the steps that we are following in case of creating the ridge regression that we will be seeing? My screen is visible to you, right? Everybody can see my screen?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
okay, okay,
Yes,
great.
ma'am.
So we'll just type it down, steps followed. So what are the steps followed that we'll be discussing? Just a moment. Yes. So the very first step that we will be considering is collecting data. Collecting data. The next stage that we are going, that is pre-processing. That we need to do. The third step that we need to consider is we need to split the data. We need to split the data accordingly. So when we were splitting the data, after splitting the data, we need to fit this ridge regression model. So we need to fit the ridge regression model. After, so what we are doing is, in case of this ridge regression model, what are the steps we are following? We are training using the formula that we have gone it through. Like this formula, we are training it. Like for this, we are training with this formula. Okay. So where we are getting this L2 penalty. Sorry. So here what we are doing, we are training the model, training using L2 penalty we are doing, and next we are choosing the alpha value. This A value we are choosing. That is, this is a hyperparameter that we are actually choosing. Choosing A value. Okay. So A is not normal A, that is this A in the code, in the formula, this A value, this A value, that is a hyperparameter that we are considering. Okay. So after this, after fitting the ridge regression model, what we are doing? We are doing the hyperparameter tuning that will make our model work better. Hyperparameter tuning. So we are doing hyperparameter tuning where we are using cross validation to best, we are using the cross validation to get the best value of A. Okay, using cross validation. We are using cross validation, and we are for this you can check it through, like we will be learning accordingly there, you will be getting it through how we are doing this. We have already learned how we are doing this parameter tuning, and we will be eventually getting it through how we are doing in hyper parameter tuning cross validation based on cross validation, how we are doing this hyper parameter tuning. And next, we are doing the interpret coefficient. We need to interpret the coefficient. We actually need to see how reduce the value based on the weights that we are putting in, right? So that's why we need to check. So we it will interpret the coefficient. That is this B0, B1, B2. These are actually the coefficient. This value it will interpret. Okay, interpret coefficient. Okay, so it interpret coefficient. So this actually are the steps that we need to follow to showcase our project accordingly. Okay, so let me just go through and give you the vivid idea how we have understood and what actually we are doing in this case. So for this, you need to learn or understand how we are going ahead and working with this, working and finding this variables like this coefficients actually B0, B1, this value we are going ahead. So we know that this ridge regression is actually a special type of linear regression. So we'll take an example of linear regression, and based on this, we will take into consideration and will choose how, like, we will be getting a more vivid idea how this we are getting this we are interpreting this coefficient, how this value B1 and B0, B2, this value has been actually calculated. Okay, so you can recall this example, right? Just a moment. Yes, this example you can recall, right? Everybody, like where we have taken the value of x according to the size of the room and y as the price of the room, right, guys?
Yes, ma'am.
Yeah. So we'll take this data for because we have already discussed on this. So we'll just take this data and based on this only we will learn. Okay. Just a moment. Let me scroll down. Yeah. So for linear regression, what we are doing, the formula that we are working, that is y equals to b0 plus b1 x. This is the formula because we are having the input or the feature that is y and the output or the features that is y and x, that is the input value we are getting, right? So we need to take into consideration. So B0, what B0 actually we are calling it intercept, and this B1, what we are actually calling it, we are calling it slope. Okay, so when we are getting this intercept, or how we are getting the intercept, when the y value of y actually value of y, this actually is value of y when x value we are getting as 0. Okay, and slope, that it is that what it says, how much y actually changed when the x increased per unit. Okay, or 1 unit if the value of x has changed, how in what purpose the y value has changed. This b1 actually says it. Okay, clear, guys? Understood?
Yes, ma'am.
Okay,
Yes, ma'am.
so this actually is the formula that of slope and intercept. So this formula we are actually using, that is xi minus x bar. X bar actually mean value of x. So we need to find this value B0 and B1, right? So how we are doing it? So we are doing B1, we are creating B1, that is summation xi, that is, okay, let me just paste the code up here. Yes. So this each of the value is actually creating x1, that is for one time it will be 100, next time it will be 1500, next time it will be 2000, and fourth time it will be 2500. This is how the value of xi will change and yi will change in this format. Okay, this is summation xi minus x bar yi minus y bar by summation of xy minus x bar whole square. This is how we are getting B1. B1, that is the slope value we are getting. Okay. And next B0, B0 actually is what it is. It is the intercept. So how we are getting the intercept? We are getting y bar minus B1. This value is required. So B1 into x bar. Y bar, that is mean of y, minus B bar, B1, that is the slope value, into that is this mean of x value. Okay, clear, guys? Clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So next we are being given with the data, right? So we'll just see what is the given data. So given data for x, we have taken into consideration what you can see: 1000, 1500, 2000, and 2500. So we'll be putting it like that for easier perspective. 2000 and 2500 we have put, right? Next, we are taking the y value into consideration. So what is y value? Y value we are getting 1,50,000. If I'm not wrong, let me check. Yes, 1,50,000 to 3 lakhs that we are getting. So 1,50,000. Next is 2 lakhs. Next, we are taking into account as 2,50,000 and 3 lakh basically, right? So this is my given data. So now I need to calculate the mean value. So because I am needing this x bar, y bar, so I need to get the mean value. So x mean of x, let me write it like that, mean of x. So I am denoting it with x dash, uh, x dash, okay? So because putting bar is difficult, I'm putting x dash for the reference. So what we are needing to do, we will be doing 1000 plus 1500 plus 2000 plus 2500 we are putting, and we are multiplying it, like dividing it, adding it first, then dividing it by 4, right? So what we are getting? So we are getting 7,000 by 4, and we are getting 11750, right, guys?
Yes, ma'am.
Yeah. So this is how we are like doing the mean of x. Similarly, we will be doing the mean of y, because according to the formula we will be needing that, that is y dash, that actually is 1,50,000. Sorry, 50,000. Let me just copy paste it. We'll be just adding it round. And we'll be dividing it by 4, because there are 4 values we are there: 1, 2, 3, 4. So hope everybody knows how we are taking the average value, how we are getting the average value. So it would be like 9 lakh, sorry, 9 lakh by 4, that we will be getting it around 25000, right? So this is how, so this is the mean value of x we have got. This is the mean value of y that we have got. Okay. So now we need to calculate the B1. So for B1, we need to calculate xi, just a minute, xi minus x bar and yi minus y bar. First, we need to calculate this too, and then we need to do the summation, right? So how we are doing it? Let me just show you. For first time, we will be taking this, that is 1000, sorry, for xi minus x bar. This specific part we are considering up. So first we will be taking the first value, that is 1000, minus what is the mean value that I am getting, that I will be doing, that is 1750. So what actually we are getting? So I guess you people can do it, right?
Yes,
Right,
ma'am.
guys? Yeah. So
Yes,
what
ma'am.
we are doing, we are doing in next step, that is 1500 minus 1750. So what we are getting? You people tell me what we are getting. What is the difference that we are getting? 2000 minus 1750. So what we will be getting? Tell.
250.
Yes, right. So next, what we will be taking, 2500 minus 1750 we will be doing. So what we will be getting? We will be getting plus 750,
750.
right? Yes,
750.
exactly. So this is how we have taken this value. So now we need to go ahead and check for y minus y bar, this value, right? So this value we need to check. So let me just put in. So first value is 1,50,000. So like minusing that with, or subtracting that by 1750. So what we will be getting? We will be getting around
Ma'am, it's
75,000, like minus.
2500.
2
Y bar
lakhs
is
Yes,
25,000,
250.
yes,
ma'am.
yes, yes, right. 225,000. Right, exactly, right. So what we are getting it round, we are getting around minus,
Minus
we will be getting
75,000, ma'am.
75,000, right?
Ma'am, Y bar
So,
value is 2500, right? Yeah.
sorry? Yeah, we
Nothing,
are
ma'am. You're
doing
right. You're
xi,
right.
xi minus x bar. By mistake, I have put in the x bar value only. Yes, you are right. That is yi minus y bar. So we need to put this value, this first variable, that is first variable of y, that is 1,000, 1,50,000 minus y bar, this value, that is 2,25,000. We need to minus it. We are getting minus 75,000. Okay,
Yes, ma'am.
got it? Yeah. So next we are doing y minus y bar for the next, that is 2 lakh, 1, 2, 3, 4, 5, yes, minus 2,25,000 we are doing. So we are getting around minus 25,000,
25,000.
right? Yes. So next we are doing what? Next we have 2,500, sorry, 2,50,000 we are getting, minus we are doing 225,000 that we are getting 25,000 plus 25,000. Next, what we are doing? We are doing 3 lakhs minus 225,000 that we are getting 1, 2, 3, 4, 5. Yes. Then we are getting 75,000. Right? Understood this much? Understood?
Yes, ma'am.
Yes, ma'am.
So,
Yes, ma'am.
so what we will be doing? We will be doing for first, this one will be multiplied with this one. Okay? Because this is the first xi minus x bar for the first case. So this one will be multiplied with this one, that is, will be doing minus, just a minute, minus 750, I guess we are getting, yes, that will be multiplied with minus 7500. 750, like 75,000 actually, right? So by doing this, what we are getting? So I need to just go ahead with the calculator, just a minute. Yes. So minus minus will get into the plus, then we will be getting 56,250,000. Okay. So similarly, we'll be doing for the next step. So let me just, you can understand what we are doing. We are doing 2500 into 2500, that is 25 into 25, that is 225. And there are 1, 2, 3, 4, 4 zeros. So it will come up to be, and minus minus, we are getting positive, that is 625,000,123. 4 zeros would be there, right? Next, we are doing what we are doing. We are doing here, it is positive 250 into 2500. The same thing we will be getting, that is 625, 4 times 0, that is around 26 lakhs, right? 26 lakhs, 50,000. Here also 56 lakhs, 25,000. Here in this form, we will be getting again 56 to 50,000. 4 zeros will be there. Yes. Yes, right. Okay. Understood what we are getting. So these are the values of xi minus x bar. This value we are getting xi minus x bar into yi minus y bar. So this we are multiplying separately. So this actually, this values we have got separately. So now we need to sum it off. We need to sum it off. So what we'll be doing? We will be adding this up. And in result, we will be getting, just a minute, it's getting out 5, 6, 5, 1, 2, 5. We will be getting 0, 0, 0, 0, 0, 0. Clear? Understood what we are doing? This part we have did the summation part only. This part we have only completed. This part. Clear? Understood?
Yes,
Yes,
ma'am.
ma'am.
Right?
Yes, ma'am.
Okay, fine. So similar way we need to do x minus x bar square. So we already have the value of x minus x bar. So we need to square it up, like 750 into 750 we need to do. Again 250 into 250 we need to do. So in this way we will be getting the value of x minus x bar square. So next we are doing x minus x bar and we need to square it down. Okay. So for this, first what is the data that we are getting? 750. So 750 into 750, that is 5625, 562500. That is the data for the first. Next, we are going and checking for 250 into 250, that is 625, and there are two zeros, so there would be two zeros up plus, sorry, we need to do 62500, again 62500, because we are having the same data like in the minus, like 250 and 250 we have got. So similar, last also 750. So this same data we will be getting 562500. Right? This much understood?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Okay, got it. So now we need to do the sum operation up here. So we need to do the sum of this. So we were getting, after doing the sum, we are getting the value as around 1250. This. This is the value we are actually getting after doing the sum. Right? So we are done with, for this, we are done with this part and this part also. So now we need to do the division. Right? So we need to get B1 value. So B1 value. So the first is what it is. You can, we have to check this one. This one is the value. Okay.
Excuse me, ma'am.
Yeah.
In about there is value x. Can you please scroll up?
Yeah.
Here is first some x value which is like in the lakhs value, and in the next that is in thousands. So it may be incorrect or missing zeros.
Why you are
Sum
thinking it
equals
like
to
that? Sum equals to, yeah, this actually we are doing it. You add it up, no? You add the values.
uh, in the in second value which is 62,500.
Yeah.
I'm not getting this value.
You add this to value to 25,000 into 25,000. So 25 into 25 gives 625, and there are how many zeros? Three zeros. So we have got ahead. Sorry, just a minute. Yeah. Okay. Just a
I
minute.
guess zero is missing.
Just a minute. It is yi minus y, right?
Yes, ma'am.
Okay. Okay. This one you are telling, right?
Yes, ma'am.
This is actually x minus x bar. So what actually x minus x bar? So this is actually, so it is 250, not 2,500. That was, I was looking for yi minus y bar. This is 250. So
Yes, ma'am.
25 into 25, that is 625, and two zeros. So this two zeros.
Okay, and first value, ma'am, please. Uh,
This one, this is
yes, ma'am.
750. So I
Yes,
have
ma'am.
taken the same, I have shown you this data because there is the repetition is same 75, 25, 25, 75. Same here 75, 25, 25, 75. But there is value, this is in thousand, this is in like 750, right?
Okay, okay, ma'am.
So that
Yes,
is
ma'am.
actually the case. So it
Okay,
is
ma'am.
actually like that. Understood? So 75 into 75, that is 5625, and 750 into 750. So two zeros. So that's why two zeros that has come up. Okay. Understood? Clear?
Yes, yes, ma'am.
Okay. So after adding, we got it this value. So we have got the value for this. That is the value of xi minus, like this previous value we have got. This value actually we have got this, and the xi minus x bar value we have got this. So we'll be dividing it round. 1250000. This we have actually got. So when we have got it down, so the value we have come up would be 100, right?
Yes, ma'am.
Six. So there are six zeros in the numerator and four zeros in the denominator. So we'll get 100, right? So value of B1 we will be getting as 100. Now we need to compute for B0 value, right? So B0, what it is? Y dash, like Y mean minus B1 into X mean, right? So we already know the value of X mean and Y mean. So where we have calculated 1750 and 225000, right? So we'll add it on like this. That is 225000, sorry, 000 minus 100. That is the value of B1, and X bar we have got 1750, right? Right, guys? I have put it the
Yes,
correct
ma'am.
value.
Yeah, ma'am.
Yeah. Okay, fine. So it would be 225000 minus 175000. So it will be around
50.
50,000. Yes, 50,000.
Ma'am,
So
it's
we have got it.
50. Yeah.
Sorry, what 50? 2,25,000 and 1,75,000. So the difference is 50,000. We are not taking
Yeah, ma'am.
2,225 minus 175, right? So there is three zeros that is there. We need to add that. Okay, understood?
Yeah,
So
ma'am.
how we are
Yes, ma'am.
calculating this B1 value and B2 value? So now our equation, that is y equals to B0 plus B1x. This value now would come up to 50,000 plus we are getting 100x, right? Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, got it. So this is actually how we are doing it, how we are actually calculating it. So based on this, when we are putting it into the form of ridge regression, what it does, so we are adding an extra penalty, right? So in case of this, in case of linear, the loss that we are getting, that is y minus y bar square. That is the cost value that we are getting. But in case of ridge, what we are getting, so see loss for linear regression, that is linear one, that we are actually getting, that is sum, that is the summation basically. We are doing y minus y, that is actual minus predicted value, that is the sum of squared error. Hope we have discussed last day, hope you all remember. So this is the loss one or the cost function that we are actually getting for linear. In case of rigid, what we are doing, sorry, ridge, we are doing ridge, we are getting the loss. But just a minute. Loss for ridge, we are getting it round. So we are doing the same thing up to this. Up to this, we are doing the same thing. Then what we are doing, we are just adding up. We are just add. What happened? Sorry, just a minute. So we are just adding up this value, that is alpha, that a value with sum. What we are just a moment, with summation that is b value, that is bi square. This part we are adding in case of loss of ridge regression. Okay. So in this part, if suppose the value of, because this is adding up, like this is in the multiplication format. So if we are just having this value a alpha value or a value we are getting as 0, so it will be similar to linear value, the loss of linear. Then if the value of a, that is small a, basically this alpha value here, this a value, if it is 0, so we will getting the loss of linear. Then that problem is converted into the linear based problem. Clear? Understood, guys?
Yes, ma'am.
Okay. So if the value of alpha is large, then the coefficients are what actually we are doing. The coefficients are actually forced to be small. Like we are doing reducing the variance, and to prevent the overfitting, we are just reducing the variance to reduce the overfitting, to like to prevent the overfitting, we are actually reducing the variance. So in simpler form, when we are going ahead and without regression, suppose we are taking into consideration, then in case of ridge regression, the value is like b0 plus b1 x1 plus b2 x2 plus dot dot dot, we are going ahead till bn xn value, right? So in this case, suppose b1 we are in normal sense, in linear sense, suppose we are taking the value as b1 equals to 0, and b2 value we are getting it as around 90, suppose. But in case of ridge regression, where the value of alpha is is greater than 0, not equal to 0. If it is equal to 0, then it will be a linear regression. If the value of alpha is greater than 0, then what happens? This value of b1 get lesser. We can reduce the value of b1 and b2 to prevent the overfitting condition. Okay, so the value of b1 will suppose get into 70, and b2 suppose it get into 60, in this range. Okay, so why this b1 and b2 value is important in case of ridge regression is understood, and how we are calculating it in case of linear regression, and how we are implementing it in case of ridge regression is clear to you?
Yes, ma'am.
Yes, ma'am.
Everyone
Yes,
clear?
ma'am.
Understood? Everyone?
Yes, ma'am.
Yes, ma'am.
Any
Yes,
Yes,
ma'am.
question?
ma'am.
Yes, ma'am.
Any question? No question, right, guys?
No, ma'am.
Okay, fine. So up to now, I guess everything is clear. So we'll move on to the collab sheet, where we will be going ahead and plotting this, solving this with the help of a code. Okay, let me just find the collab file up. My screen is visible, guys?
Yes, ma'am.
No, ma'am.
Visible
No,
or not?
ma'am. Not
No,
yet, ma'am.
no, ma'am,
Okay,
not
okay,
visible.
No, ma'am.
okay, fine. Now,
No, ma'am, not yet.
No, ma'am.
No, ma'am.
No, it is not.
just a moment. Now also not visible?
Yes,
Yes,
ma'am.
ma'am. It
It's
is.
visible, ma'am.
Yes, ma'am.
It's visible. Okay, okay, fine. Just a moment. Yeah. So yesterday we have got around this linear regression, logistic regression, and this is ridge regression. So what actually we are doing, we will be getting into. Okay. So here, the similar way we have imported the libraries. We have just for an example taken in data set where the data that we are considered up is area, room, and price. They are the keys. Against this, we are getting the value. So we have created a dictionary, converted that into data frame actually. Okay. So now we need to see what are our target features, what are the features and the target value that we have to consider up. So price, we need to predict the value of the house. So that is our output. So that is why. So that has been created as target. And other two features have been kept as for the has been kept for the other purpose, that is the independent variable x. The value of x has been created like that. Understood what we did? See here
Yes,
we
ma'am.
have multiple, we are dealing with multiple independent variables. So here we have taken for a simple simplicity purpose, we have taken two independent variable, that is area and room, and we have taken the price that we need to predict it later. So we it is a dependent variable and the independent variable is this two. So we have created like as we have previously in the while we have gone ahead, we have taken the values also into consideration. Here also we have to take the value separately to give the model, right? So after that we have to train the like split the data to train the model. So we have split into x train, x test, y train, y test, and we have taken the test size as zero point 0.2, that is 20% of the data we have kept for test purpose, and we have split the data like this. Now we have to create a ridge regression model. For that, we have taken ridge regression. We have created this variable and under which we have taken ridge, and alpha value we have considered as 1. So alpha value, like you can recall, right? Just a moment. This value, this A value, this A value actually we have taken because that we do get the authority to take the value according to our wish. So we have taken the value of A as 1. Okay. So, and then we have fitted the model. So this actually what this does, this trains the model and do the regularization, this part basically dot fit actually. Okay, then we need what we did, we have to predict it. Okay, so it what it does, this part actually take a text data from the X test. It takes that X data and try to predict the house price based on the test data that it has taken into consideration. Now, what we are checking, we need to do the evaluation. For that, we are checking the prediction purpose we are checking, we are doing the coefficient we are checking, we are doing the intercept value we are checking, and MSE, that is mean squared error, we are checking. Okay. So after running the code, we are getting the prediction that is 175. That is the prediction that it has came up with the value, the house price prediction based on the data that we have given. So previously the data is like this. So maybe any of this is the actual data that has been given. So some of the data might be in this section, it has kept it and it has choose any of the data like that. And it has given the prediction as 175. So any of the data in between in this value, it has predicted actually. Okay. So coefficient value, we have checked it accordingly. So it is the coefficient that is B1, B2, this values, the B0, B1 values, this have actually predicted. Then the intercept values that we have to check in through, that is B0 value, we have checked it through, and MSC, that is the mean squared error. Okay. Understood, guys, how we will be plotting it?
Yes, ma'am.
Yes, ma'am.
So, so what you thought? Like, is it better in this rigid regression is better than the linear regression? What is your point?
For
Ridge
multiple
regression is better.
linear regression, it is better, ma'am.
Sorry, I didn't get you.
For multiple linear regression, this rigid regression goes well to
Yeah,
avoid
because
overfitting.
yes, exactly. So that is exact thing. So in case of we actually simple linear regression in very small less cases where we actually work with only one single variable. We in general term in any of the term or in any project you will be working further, you will be definitely working with multiple of independent variable, right? So you'll be working with multiple of independent variable you take into consideration. So in that realistic form, you can think that this ridge regression is better because it helps us to prevent this overfitting, right?
Yes, ma'am.
So next is the lasso regression. So you can think this is lasso regression. This is L1 regularization. So it is also a type of linear regression. It includes L1 regularization. Okay. So ridge was according to L2 regularization, and lasso is L1 regularization. Okay. So it mainly used to prevent overfitting and perform feature selection, right? So in case of rigid, what we do only it is only used in case of preventing overfitting, but lasso it not only prevents the overfitting but also perform feature selection. Okay, so got it? Understood?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Yeah. So what it means, like in what actually it does, in case of rigid, it has like shrinking the value. Like this B value I have shown you, right? Okay, just a moment. Yeah. Here I have shown you, right? Previously the value is like this. If the value of alpha we are getting like greater than zero, the value of B1 and B2 is getting shrinking. Like it is getting smaller based on what we have actually predicted, right? So this actually is the work of ridge regression. But in case of lasso, but it never, the thing is, ridge regression never make this value as total zero. If it is totally coming up to be zero, it is forming into linear regression. That is of no use then. So it will never make this value to zero, right? So in case of ridge regression, we are never getting this value as zero. But in case of lasso, we can shrink some of this coefficient exactly to zero based on our need because here we are doing the feature selection also. Understood? What is the difference?
Yes, ma'am.
So
Yeah,
it what lasso actually do? It actually remove the unimportant features automatically without our intervention. It just remove the unimportant features automatically. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
yes, ma'am.
Okay.
Yes, ma'am.
So, okay.
Yes,
So
ma'am.
Yes,
Okay,
ma'am.
okay, great. Fine. So in case of lasso, what we are doing, we are going ahead with the cost. So you have seen the cost for cost or loss, any of the value for ridge. So it is like this. We are doing sum and we are doing the square, right? So in case of cost for a loss value of lasso, just a minute, loss value of lasso, what we are doing, we are actually taking into account this SSE value, that is the sum y minus y bar whole square, that is actually sum squared error. Okay, sum squared error we are doing, plus what we are doing, plus we are taking this alpha value and we are doing this sum operation we are doing, and it is we are doing over the modulus of bi, that is the coefficient. Okay, so technically you can see here we are doing the squared operation, and here we are doing taking the mod value. Okay, understood? So bi, that is actually the coefficient that we are taking into consideration, that is the slope or the features we can think it of, coefficient of the features like this one b, the b1, b2, b3. Since bi I have written, it will come from B1 going down to N. For all this value, we will be taking into consideration. This A or this alpha value, this A value is what it is. It is actually the regularization strength. That is how much penalty you want to apply. This is on you, how much penalty you want to apply. So this is what it is. And for this case also, it can never be, the value of alpha cannot be zero. If it is zero, it will convert to normal linear regression. Okay, so what is actually the use of lasso regression? So it reduces overfitting just like the ridge regression. Along with that, it has other features, that is, it can select important features automatically. That is, it can do the feature selection. Eventually, it is useful when you have many features into count and you want to suspect some of the, you want to check in which features are important and which features are not. So in that case, you can definitely use a lasso regression. A lasso regression will itself remove some of the basic unused fields or the features that are there. So and it also makes the model that we are working on easier and interpretable. Okay, understood, guys?
Yes, ma'am.
Okay,
Yes, ma'am.
fine.
Yes, ma'am.
Okay, fine. So let us just check it accordingly. So before that, we can take an example in the similar section. Here, we have taken the example in Lasso. We have taken the similar example of area, room, and price, right? Here also, area, room, and price we have taken. Suppose we have the field like room, age, then garage value we have, garage field we are taking into consideration, garden, price, all these values are taking. So you can definitely see this age value is of no such requirement. What is the age of the house? Generally, we don't take into much of the consideration. The main area like that doesn't directly correlate with the price, right? The age. So we can definitely remove that. So in if we are taking into consideration in lasso, then lasso will by itself it will remove this part, this age part. Clear? Understood?
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. So let us just go through with the code. So similarly, just like this one, just like this ridge regression, what it does, it has taken the libraries, the same example, same kind of example we have, the same example actually, we have taken it down, created the data frame, converted with the features and the target, what is the X value we have marked, what is the Y value we have marked, split it the data accordingly. Now created this lasso model. Here we have taken the alpha value at 0.5. Previously here we have taken as 1. We have taken the alpha value as 0.5. That is our based on our choice we have taken. Now we have fitted it. Now we have gone ahead with the training part, and this is the performance checking part. So here it has printed the values like this. Okay, understood?
Yes,
Clear,
ma'am.
everyone?
Yeah, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Any
Yes,
doubt
ma'am.
till now? Guys, any doubt till now?
Ma'am, can you
No, ma'am,
explain the
I'm good.
difference between lasso and ridge regression, ma'am?
I told you, right? Just now I told you, right? Okay, fine. Let me tell you again the basic difference. So, in case of lasso, what we are doing, we are in the square, in the loss function, you can see we are doing the squared coefficient we are taking this part, bi square we are doing basically. Here, everything we are doing, but we are taking the absolute value of the coefficient. That is the mod value of the coefficient value we are taking. Okay, so this is number one. In case of lasso, what we can do, we can the coefficient that is b1, b2. You can see previously we have done it. In case of ridge, what we did, we can just shrink the value. We can just shrink the value to 70, 60 in this range, but it cannot be changed shrink to zero. Okay, this value can never be shrink to zero. But in case of lasso, we can definitely shrink this value to exactly zero. Okay, so and lasso offers feature selection, but ridge not support any feature selection. And in case use case, if you can think of, in case of ridge, we are going ahead and preventing overfitting, and also it is used in case of multicollinearity. If there is any multicollinearity seen in the data, in that case we can see and think about ridge regression. And in case of lasso, if we have a like the data set is huge and the number of features are more than the number of the rows, then we are using lasso. Okay, or if we have a priority where we need to check for the feature selection on the data set, then we use lasso. Understood?
Yes, ma'am.
Clear? Everything clear?
Yes, ma'am. Clear, ma'am.
Okay, fine. So let us go ahead with the next one. Let me check what is the next one. hmm Okay, that is elastic net regression. So the next is the elastic net regression we will be discussing. Okay. So what is elastic net regression? So elastic net regression is actually what it is. It is the combination of ridge, that is the L2 regularization, and lasso, that is L1 regularization. Okay. So it is actually the combination of rigid L2 regularization and lasso, that is L1 regularization. Okay. What it does, it prevents overfitting just like ridge, as ridge does, and also lasso does in the similar way. And along with that, it does perform feature selection. Okay, where there is a condition, we need to prevent overfitting and also we need to perform the feature selection. Then we go ahead with this elastic net regression. This actually combines the previously two understood models and come together to form one single model, that is elastic net regression. So the idea is simple. The similar like that. The equation is this only for all of this, like for ridge, lasso, and elastic net as well. But the cost, or that is the loss, or the cost function has been changed. That is the cost function that we are getting in through. We are getting here. We are doing. we are actually adding all of it together. What we are doing, we are just a minute. What we are doing in case of ridge, we are doing this, right? So we are actually adding up here. Along with that, we are adding this as well. In case of elastic net regression, here there will be two values. Here A1 and A2, two different values we need to take into consideration. And this is actually the cost function or loss function of elastic net regression. Okay, got it? Understood? A1 is the L1 penalty and A2 is the L2 penalty. Okay, got it, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
so similar way we are
Yes,
doing it.
ma'am.
Similar way we are doing it. So why we are using elastic net? So it handles the high dimensional data where there are many features we need to choose in the features. It actually what Ridge and Lasso does in all those fields where we are needing specifically them. In general, we can use this and we can use this elastic net. Okay. So this is actually it is more flexible than other two because we can get both the fields up there. We can also prevent overfitting at the same time. We also we can take it up and use the forms where we are uh, taking into consideration the feature selection. Okay, so let us just take into consideration and go further uh, and do the coding section for that.
Excuse me, ma'am.
Yeah, tell.
Ma'am, like how the process of shrinking goes,
Sorry.
how the process of shrinking goes here.
So the cost function is different, right? So based on the cost function, the value, I told you how this B1 and B2 value is calculated for linear regression, right? So in there, the cost function is different for linear regression. Now, while we are checking for different, this cost function is different for reach also, loss also, and also for this elastic net also, right? So since the cost function is changing, the value, since we are taking this value alpha for ridge, the value is getting shrinking because that is also affecting the for how we are considering B1 value or B2 value, right? The coefficient value actually. Understood?
So the alpha 1 value shrinks to a certain value, and alpha 2, in case of feature selection, it shrinks to 0,
No,
kind of.
no. So this is alpha 1, alpha 2. This is coming in case of elastic net regression only. Previously, we have only one alpha value, right?
Yeah,
There is
ma'am.
only alpha. There is no alpha 1, alpha 2. And we haven't discussed about elastic net. You are asking how it is getting shrinked, right? So if the value of A is getting, because the alpha value has some effect on this value, on the calculation of B1 and B2, right? So previously in linear regression, we don't have this alpha value. The alpha value was 0. But here, in this case of Reg and Lasso, we have this alpha value into count. So this alpha value does some effect on B1 and B2 values, right? So this is how, since that is putting some impact, that is why the value from the original, it is getting into shrink form. Like we are lessing the value. Whatever be our coefficient, we are putting the values a bit less so that we can prevent the overfitting part. Got it?
Okay, ma'am. Yeah, ma'am, got it.
Yeah. So in case of elastic net, let me just show you how we have write the code. Similar manner, same example, dataset checking, feature and target. We have initialized split data we have taken into consider, and here we have taken that is L1 ratio, that is 0.7 that we have taken into count. That is mostly that is L1, that is the lasso effect, and some L2, that is the rigid effect. So we have taken L1 ratio, that is 0.7, and alpha, this is the overall penalty strength. Okay, that we have taken into consideration up here. And similarly, we have predicted and we have got the value like this. So here you see the mean squared error is less, very less. Here we have got 18 and here we have got 18.45. Here we have got 18.123. So see, for this, the MSC value is 18.45. So it is huge. When we have gone ahead with lasso, it has improved a bit because the mean squared error, the lesser the value of mean squared error, the better performance we will be getting, right? So 18.123, that is lesser value we have got for lasso. And now in case of elastic net, we have got 17.99, right? So it has predicted the same thing, but see, the prediction was kind of same, 70, 175. The prediction has also improved a bit, but kind of same only. 175.70 for Ridge. Next, in case of Lasso, 175.74, 0.04, it has gone better. In case of Elastic, it has gone better for 0.05. At least a bit has it has improved, but MSC rate has changed quite a bit because here it was 18, it was 17.9. Understood?
Yes, ma'am.
Yes, ma'am.
Everyone,
Yes,
everyone
ma'am.
understood? Okay.
Yes,
So
ma'am.
Yes,
what
ma'am.
what actually
Yes,
we are
ma'am.
doing in case of elastic net? So elastic net is actually linear regression plus L1 plus L2 penalties, right? So what actually it is, we are combining this ridge regression, along with that we are combining lasso regression. It handles uh, correlating features actually, just like it does in case of Ridge and Lasso. It does the feature selection. So the both the effect we are getting in case of elastic net, we are this here we are not going ahead or taking into the form how much we are shrinking the value. Shrinks unimportant coefficient towards zero, that is actually going ahead and doing the feature selection that lasso is actually doing. And next we are considering here the hyperparameters, that is alpha, that is the strength. Here in this case, you are taking alpha as 0.5. That is the strength of regularization, and L1 ratio, this one, L1 ratio we are taking into consideration. That is the difference between lasso, that is L1, and rigid L2. So that we are taking into consideration for working. Okay, understood? So what simply we can think of rigid reduce uh, all ingredients you can think of, or all coefficient you can think of to a little. Lasso, what it does, it removes unimportant ingredients completely. And what elastic net reduce, it reduce some and it reduce some of the ingredients and remove some of the important ingredients. So it is best for both the worlds, right? Understood? Clear? Everything clear?
Yes,
Yes,
ma'am.
ma'am.
Clear, ma'am.
Okay, fine. So next we will check on to the matrix, on one matrix on what matrix we can go through. So we have definitely come across. I guess you all people are well known about the matrix evaluation, on what matrix we have gone ahead. So here basically for this model we have taken into consideration the prediction coefficient value we have taken, intercept we have taken, and the MSE, basically MSE, the mean squared error value we have taken into consideration. But when we are working with higher level models or anything, we generally take the matrix for confusion matrix. We generally consider we consider the accuracy, we do consider the precision value, we do consider the recall value as well. So we'll try and see some of them today. So we do have, suppose we can take one example and based on that we can think of. So anyone have any idea what confusion matrix is? Okay, let us just take an example. Based on that, let us discuss. Okay, so let us just take one example up for matrix evaluation. So basically, what we are doing, we are suppose taking a classification problem. Maybe the spam or not spam anyone, or we can take the medical test also of the patient. Okay, so there are two categories. Here the model can predict in two types, right? So two types it can predict. The first one is might be in this case if we are taking into consideration the medical test, then it will take two types of prediction it will give. Either it will all or also if we are taking into consideration any of the classification problem, we are getting two types, either positive value or negative value, or spam or not spam, this type. So for this reference, we are taking the medical test value example only. Okay, clear guys what I told?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Am I audible to you? I'm not
Yes,
getting your
ma'am.
voice.
Yes, ma'am, you're
Okay,
audible.
Audible,
Yes,
ma'am.
ma'am. Audible.
screen is also visible.
Yes,
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 ma'am.
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 Yes, ma'am.
Okay, fine. So for two times we will be getting either positive value we will be getting or negative value. So positive, or second one would be negative. So how we will be taking into consideration? Now in this case we need to check what actually based on that we need to check. So first is the confusion matrix. Let me clear you what confusion matrix is. So what actually is confusion matrix? So confusion matrix is actually a table. Okay, so that actually shows how well the classification model has actually worked. Okay, so there we generally take four values. One we take as actual or the predicted value, actual value and the predicted value. Then we take the predicted positive value and the predicted negative value. Okay, so what actually we are taking? We are taking actual value, that is actual positive value, and actual negative value. Against that, we are taking into consideration predicted positive, that is true positive value, how much we are getting, and true false positive value, how much we are getting. Same for predicted negative value, what we are getting, false negative value, how much we are getting, true negative value, how much we are getting. So it is a matrix actually, so it is taken in the matrix format. So actual value, or let me just create the table for you. Predicted. Then we will be taking into consideration predictive positive, predictive positive value, and predictive negative value. Okay. So here we will be first checking into actual positive. What is the actual positive value that we have to take into consideration? So for under predictive positive, we will be taking what is the true positive. True positive value, that is TF value. We need to check based on whatever be the data set and what based on the actual value and predicted value, how much the model has predicted correctly. That is true positive. How much based on the positive sense, how much they have taken into consideration, and true positive, it has came into place. Okay. Now, for this, we will be checking for actual negative. What is the actual negative? So here we will be checking off for false positive value. So it will check for FP, this value. So for the negative prediction, what it will be taking into consideration? False negative. False negative, that is Fn. And further it will check for true negative. So this actually what's there in case of confusion matrix. So what true positive says? True positive, actually what data we have taken into consideration, the medical test. So medical test, suppose of diabetes. Okay, the patient is having diabetes or not. So what true value signifies? True value that is true positive signifies. It signifies the model correctly predicted diabetes. Okay, when the patient actually have diabetes in actual sense, when the patient actually have diabetes, the model has also predicted diabetes. That is true value, true positive. Understood what I told?
Yes, ma'am.
Yes, ma'am.
Okay. So false
Yes, ma'am.
positive, what it is?
Yes.
When the model predicts diabetes, but actually the patient was healthy. Patient do not have diabetes. So that is false positive. Okay. Next is true negative. What true negative is? Model correctly predicted no when the patient is healthy. Okay. So model correctly predicted no when the patient is healthy. In this sense, we are taking true negative. Okay. And false negative when the model predicted no diabetes. Actually, when the patient actually has diabetes, that is false negative. Understood? This much everyone understood?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
So suppose we are taking for a reference, I am saying, suppose we are taking a data set of 100 people, 100 patients. Okay. So 100 patients, we are taking the data set. So actually, suppose 40% have diabetes. And therefore, what it says that is 60% is healthy, right? Or they doesn't have they have no diabetes. Okay. So this is the actual data. This whatever I am saying, this is actual. Okay. Now we will come for the model. So suppose the model predicted about 35 of the data correctly. Model prediction. So 35 it has predicted correctly. Okay. And it has got the TP or the true positive value or any of the missing value in this case. We can think it of that is 35. It has as it has done correctly, we can put it as TF because it is the true positive value. And next, the false negative that it can think we can think that 5 it has predicted wrongly. That is false positive. It has taken into consideration, right? Understood?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Next, what it does for this positive case we have taken into consideration. Now, we suppose the model wrongly predicted 10 healthy people as false positive. Okay, so 10 people as false positive. Okay, then what it is that is then next 50 people we have taken because there are 60 people healthy. So next 50 people would be negative, like true negative, right? We will just divide, like subtract, and we'll get the data, right? Understood, guys? What I told?
Yes,
Yes,
ma'am.
ma'am.
Confusion matrix, what would be? Then confusion matrix, it would be, first we will be putting TF. TF is 35. Then we need to put 5. 5, that is FN, that is false negative. So we'll put 5. Then now we will be putting this FP. FP we are seeing that is 10 value as FP. And then we'll go ahead and put 50. That is true negative value. So this is how we are creating the confusion matrix. Clear?
Yes, ma'am.
Yes, ma'am.
Then we need,
Yes.
then we have to say think about accuracy. What is accuracy? Anyone wants to tell?
How
Number of
accurate the model will be predicting the correct output.
Actually, accuracy tells us how many prediction went correct.
False positive.
Okay. So how many prediction went correct, that the accuracy level will tell. So what is the formula for this? That is TP
true positive
plus,
plus false negative.
yes, true positive plus true negative divided by all of this. Like TP plus TN plus FP plus Fn, all of this. That is true positive. We are taking how many is correctly predicted. So true positive, what is the true positive it has taken? Then what is the true negative it has taken? We will sum it up. That would be in the numerator, and we'll sum it up the rest all, and we'll put it in the denominator. So here in the example, we can think what is the true positive, that is 35. 35 is true positive, right? And what is Tn? That is 50. 50 is Tn, right? And we will divide it with all of the 100 values that we have taken into consideration. So it is 85, sorry, 85 by 100, that is 0.85.
85%.
Yeah, that is 85%. Right? Understood? So the model is giving around 85% accuracy based on this data. Clear?
Yeah, ma'am.
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
So we'll just continue from precision. We will be lifting off with precision and recall. In the next session, we will be doing it, and then we will be jumping off to any of the KNN classification decision tree that we will be seeing in detail, and we'll try to code it down. Fine.
Okay, ma'am.
Okay.
Okay,
So
ma'am.
for today,
Okay, ma'am.
we'll just stop our session here. We'll just wrap up our session today here. And based on that, tomorrow we'll just start off from here itself. So I guess today's session, everything is clear, guys.
Yes,
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 ma'am.
ma'am.
ma'am. Yes, ma'am.
Yes, ma'am.
Okay. So this basics, you need to clear all this basics, because eventually when you will be going ahead for any of the interviews, we don't know what type of questions they will ask. The interviewer will ask, right? So they might came into a situation, they come to very basic. So their alibi would be like they have asked the basic, very basic. You don't know, but these are the intricate part. These are the base level. So you need to understand this very well to perform any of the operation. Basically, most of us here, I guess most of us are here, we are just running the code, but what intricate details are there inside the code, most of us don't know, because we are just calling the libraries, right? Python has made it easy, but when we are going and facing of any of the interview, we need to take into consideration this, so that we our basics are very clear, right? Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Yes,
Hope
ma'am.
uh,
Yes,
hope
ma'am.
everyone understood what has been taught in today's session, right?
Yeah, ma'am.
Okay, great. Okay, then
Yes, ma'am.
we'll just wrap up our session today here. We'll meet tomorrow and we'll start off from here. Okay?
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
Okay, fine. Bye bye. Bye, guys.
Bye bye.
Bye bye, ma'am. Bye,
Bye
ma'am.
bye, ma'am.
Bye.
Good day.
Bye bye.
Bye, ma'am.
Bye, guys. You can leave.